Okay, pre-calc, today we're going to talk about geometric sequences. Yesterday we talked about arithmetic sequences, so let's see what the difference is. In a geometric sequence, it's a sequence in which the ratio between any two consecutive terms is constant. Remember arithmetic, it was the difference. Now it's a ratio. And the common ratio is that numerical ratio, and we're going to call it R. Just like in an arithmetic, it was called a common difference. So let's look at these examples. We've got 8, 24, 72, 216, ... What is the common ratio? And find the next three terms. All right, to find the common ratio, you're going to take a term here and divide. So we're going to say 24 divided by 8, and that gives us 3. Anything does. 72 divided by 24 is 3. 216 divided by 72 is 3. So our common ratio is 3, and our next three terms are 648, 1,944, and 5,832. Now you can see that in a geometric sequence, it goes up way faster than in arithmetic. So that's going to give you a clue when you look at them and you have to decide if they are arithmetic or geometric. So let's look at number 2. We got 512, negative 128, 32, negative 8, ... Our common ratio is going to be negative 128 over 512, which if you simplify that is negative 1/4. So in this case, it's going down. The negative makes it go back and forth. Every other term is positive and every other term is negative. And the fact that the 1/4 is less than 1 makes it go down instead of go up. So our next three terms, negative 8 times negative 1/4 is 2, and then negative 1/2, and then 1/8. All right, so let's look at number 3. We have negative 6.4, negative 16. Is that right? Yeah. Sometimes I can't read these. Negative 16, negative 40, negative 100. So we're going to take any two next to each other and divide. If we take the first two, negative 16 over negative 6.4, the negatives are going to cancel, and you're going to get 5/2 or 2.5. And that is R. And then the next three terms, negative 100 times 2.5 is negative 250, negative 625, and negative 1,562.5. And then the last one here, number 4. Ooh, nice fractions. Negative 243 over 32, 81 over 16, negative 27 over 8, 9/4. Okay, it's going back and forth between positive and negative. So you know R is negative. And if we take 81 over 16, I'm actually going to take some of the numbers down here instead of the first ones because they're smaller numbers. They're easier to deal with. It doesn't matter which two you take. They just have to be next to each other. So I'm going to take 9/4 divided by negative 27/8. So that's going to be 9/4 times the reciprocal of this, negative 8 over 27. 4 goes into there 2, 9 goes into there 3, and I get negative 2/3 for my R. So my next three terms, 9/4 times negative 3, or negative 2/3, is negative 3/2, then 1, and then negative 2/3. All right, that is just some basic geometric sequences. Now our equation for finding, or a formula for finding the nth term is an equals a1 times r to the n minus 1. Okay, where a1 is the first term, and R is the common ratio. And this is going to give us an explicit formula in terms of n. So that's an explicit formula. All right, let's look at some examples here. Number 5, it says write an explicit rule and then find A8. So we need to know A1, which for number 5 is 3, and we need to know R. And R we can find by taking 12 divided by 3, and we get 4. So that's an equal. I better fix that. Okay, so our explicit formula is A1 times R, oh, we know what R is, times 4 to the n minus 1. You're going to do this first and then multiply by a 3. So to find A8, that's going to be 3 times 4 to the 8 minus 1, which is 3 times 4 to the 7. You're going to do 4 to the 7 and then multiply it by 3, and you should get 49,152. Let's look at number 6. A1 equals negative 2,400, and R is, I'm going to take some of the numbers down again because I'm going to pick negative 300 and negative 600 because those are smaller numbers than negative 1,200 and negative 2,400. But it doesn't matter which ones you do. Those cancel, these cancel, and you get 1/2. So our explicit formula is A1 times R to the n minus 1. Okay, and A8 is negative 2,400 times 1/2 to the 8 minus 1, which is 1/2 to the 7th. So if you take 1/2 to the 7th, multiply it by negative 2,400, you should get negative 18.75. Okay, number 7. Let's see if we can fit them on here. A1 is 7 over 36, and R is, I'm going to use negative 42 divided by 7, which is negative 6. So AN equals A1 times negative 6 to the n minus 1. Okay, notice how I put parentheses around the negative 6, and over here I put parentheses around the 1/2 because it has to be the whole thing to the exponent. Up here with 4, I didn't put parentheses because it doesn't make any difference. But when you're putting this into your calculator, make sure you put parentheses. All right, to find A8, we're going to take 7 over 36 times negative 6 to the 8 minus 1. And this is going to give you negative 54,432. And number 8, ooh, look at that one. A1 is, how many zeros is that? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And R is, here it is negative 1/5. Okay, make sure you're dividing the right direction. This would be 800 over negative 4,000. So those cancel, and then 8 goes into their 1, 8 goes into their 5. So you get negative 1/5. And AN is 5 times negative 1/5 to the n minus 1. So A8, whoops. A8, I'll just give you the answer, is 1.28. You can go ahead and try that on your calculator. Oh, and then, of course, when we go to the next page, there's more. I thought we were done. Number 9, A1 is this, R is 3/4. So our explicit is this, and A8, you can go ahead and try these on your own. Is that? And for number 10, I'll just give you the formula. 1/2 times -3, whoops, to the n minus 1. So A8 turns out to be that. All right, let's look at the next thing. This is kind of what we did the last time when we had, whoops, when we had some of the parts and we had to look at for some of the other ones. Here's our equation. So for number 11, it says A1 equals 240, R equals -2, find A6. So we know A1, we know R, and we know N. So we can go ahead and just use that equation and say A6, right? Is that what, yeah, A6 is A1 times R to the 6 minus 1. So just go ahead and do that in your calculator and you should get this. Okay, it's just like the other one. We have 1, 2, 3, 4 unknowns. And in this case, they gave us 1, 2, 3. So we found the fourth one, number 12. If we have A2 equals -8 and R equals 4. Oh, what did I write? R equals R. R equals 4 and A10 is what we are trying to find. All right, do we know these things? We know an AN, and we know an N, and we know an R, but look, we don't know A1, and we're not looking for A1, we're looking for A10. So we're gonna have to do this in 2 steps, like the one that we did in for the arithmetic, where we had to find the D first and then go on. We're gonna have to go through here to find A1, and then we can find A10. So we're gonna say -8 equals A1 times 4 to the 2 minus 1, because this is N right here. So we have -8 equals A1 times 4 to the 1, which is 4. So we're going to divide by 4, and we get A1 equals -2. Now we can find, that was our first step. Now we can go ahead and find A10 by substituting in A1 and R to the 10 minus 1 because of this. And when we do that, we should get -524,288. Big number. Okay, number 13. I'll put our equation up here. Number 13, we have A5 equals 1/4. R is 1/2, and we're looking for A11. So we're going to have to do it just like we did the last one. We're going to have to first find A1. So we're going to say AN equals A1 times R to the 5 minus 1. So we get 1/2 to the 4th. 2 times 2 is 4 times 2 is 8 times 2 is 16, which is 1/16. So we get A1 equals, when we divide, or when we multiply each side by 16, we get A1 equals 4. That's our first step. Now we can go ahead and find A11 by saying A1 times R to the 11th minus 1. And this is going to equal 1/256. And number 14, we have a 3 equals 4/9, and r equals negative 1/3, and we're going to find a 9. Same thing. Okay. We first have to find a1, so we're going to say 4/9 equals a1 times negative 1/3 to the 3 minus 1. So this is going to be 4/9 equals a1 times negative 1/3 squared is going to be 1/9, and so a1 becomes 4. Same as number 13. And then to find a9, we're going to do 4 times negative 1/3 to the 9 minus 1, and that equals 4 over 6,561. And I'm just going to give you the answers here. Oh, no, we're going to actually do this one because it's different. Number 15, we have a 1 equals 2, and a 5, is that 5? No, a 6 equals 486. And we're going to find a 12. So now we actually have a 1, but we don't have r. So we're going to have to do it in 2 steps again. We're going to have to find r and then go ahead and find a 12. So we're going to say an equals a1 times r to the 6 minus 1. So this becomes 486 equals 2 times r to the 5th. So r to the 5th equals 243. And you have to do this problem somehow to find what r is. R is 3. You can take 243 in your calculator and take it to the 1/5 to find what this is. Because if you take this to the 1/5, you get r to the 1st power. That's our first step. Now we can go ahead and find a 12 by saying a1 times r to the 12 minus 1, and that is 354,294. And let's do the last one, number 16. We got a 4 equals 75 over 2, and a 7 equals negative 75 over 128. And we want to find a 2. Well, let me put our equation over here. Okay, we don't know a1 and we don't know r. So we can do this kind of like what we did in the last one. There's lots of ways you can do it. What I'm going to do is call this a1 and this a 4. So then I can use these to find what r is, and I can say a 4 equals a1 times r to the 4 minus 1. See if I'm doing this right. So then I'm going to multiply by the reciprocal. So I'm going to multiply this by 2 over 75, and those are going to cancel, and I'm going to get negative 1 over 64 equals r cubed. So I'm going to take this to the 3rd power and this to the 3rd power, or to the 1/3 power, and I'm going to get r equals negative 1/4. And now I can go ahead and find a2 by saying, oh no, wait, that gave me r. So there's a lot of ways I could do this. That gave us r. We're actually going to have to find a1. So let's go ahead and do that by saying a 4 equals a 1 times this to the third, because this is a 4, so this is 4 minus 1. All right, so we get 75 over 2 equals a 1 times negative 1 over 64. And so a 1 equals 75 halves times 64 over 1. And a1 equals a1 equals 75 times 32, is that right? Equals 2400. So a2 is just going to be that times negative a fourth, which is negative 600. This one should have been negative. So A2 is 600. Okay, there's different ways you could do this. I'm sure that would be a little bit simpler. I think I might have made that harder than it is, but it worked. So let's look at the explicit versus recursive formulas. Remember how we did that before? For number 17, we've got 2, negative 10, 50, negative 250. And for our explicit, we're going to use this formula that we have. And we get, so we need to know what R is. A1 equals 2, R equals negative 10 over 2, which is negative 5. So our explicit is AN equals A1 times R to the n minus 1. That's our explicit for number 17. And, oops, except it's negative 5. Sorry about that. It's negative 5. And for our recursive, all you have to do is say A1 equals 2 and AN equals negative 5, which is our R, times A to the n minus 1 for n greater than or equal to 2. So for number 18, we have A1 equals negative 4/3, R equals a half. Okay, because it's negative 2/3 divided by negative 4/3, which is 2/4, which is 1/2. So our explicit is A1 times R to the n minus 1. And our recursive is A1 equals negative 4/3, AN equals R, which is a half, times A n minus 1 for n greater than or equal to 2. There's our recursive. All right, geometric means, just like we had arithmetic means, now we have geometric means. What do you think it means? Geometric means are the terms between any two non-consecutive terms in a geometric sequence. All right, so an example. Right there, they gave you an example. The geometric means between 3 and 243 are 9, 27, and 81. So we're going to do the same thing that we did the last time. Find the indicated geometric means. And so for number 19, we've got negative 4 and negative 2,500. And we're looking for 1, 2, 3 means. So in order to do that, we need to find R. So we're going to use our equation, our formula. And we're going to pretend like this is A1, and this will be a what? 1, 2, 3, 4, 5. So we're going to say A5 equals A1 times R to the 5 minus 1, or 4. Now I'm going to divide by -4, and I'm going to get R to the 4th equals 625, and I'm going to take each side to the 1/4 power. So I get R equals 5. And now I can just go ahead and put those in there. -4 times 5 is -20, and -20 times 5 is -100, and -100 times 5 is -500, and -500 times 5 is -2,500. All right, let's look at number 20. We've got 2 and 9/8, and we're only looking for 1. So this is A1, and this is A3. So we're going to say, I'll do it over here. 9/8 equals A1 times R to the 3 minus 1, or R squared. I'm going to divide by 2. I mean, not divide by 2. Yeah, divide by 2. Or multiply by a half. And I get R squared equals 9/16. And now you should be able to see, we're going to take the square root of both of these, and we get R equals 3/4. So then we're just going to say 2 times 3/4 is 6/4, which is 3/2. And 3/2 times 3/4, look at that, is 9/8. So we did it right. So number 21, we have 243, and we have 2 means, 1, 2, and then we got -72. So this is A1, 2, 3, 4, this is A4. So we're going to say -72 equals 243 times R to the 4 minus 1. So I'm going to divide by 243. And I get R cubed equals -8/27. And when I go to the 1/3, each of these, I get R equals -2/3. So I'm just going to take 243 times -2/3, and I get -162. And that times -2/3, and I get 108. And if I do that times 2/3, I get -72. And the last one is a lot, so I'll get a new page. Number 22, we've got -960, and we're looking for 1, 2, 3, 4 means, and we have 15/16. Oh, that doesn't look fun. A1, 2, 3, 4, 5, A6. So we take A6 equals A1 times R to the 6 minus 1. And we go ahead and do this. You should get R to the 5th equals -1/1024. And when you go take each side to the 1/5 power, you get R equals -1/4. So we're just going to take this times -1/4, and you'll get 240 times -1/4, -60 times -1/4, 15 times -1/4, -15/4 times -1/4, and you get 15/16. And that's the end. All right, now a couple applications and we're done. In 2009, Ava purchased a new truck for $45,000. Each year, the value of the car depreciates at a rate of 18%. Use a geometric sequence formula to find the value of Eva's truck in 2017. All right, so let's see what we know. A1 is 45,000. Okay, that's how much that's how much it cost in the beginning. And what does R equal? what do we have to multiply this by to get what it's, if it goes down 18%, then we'll take this and multiply it by 0.82. Okay, 100 minus 18, and you get 82. And N is how many years? 17 minus, let's see, we're looking for, if 2009 is 1, and 2010 is 2, and 2003 and 2011 is 3, so 2017 is going to be 9. So we're going to say A9 equals 45,000 times R to the 9 minus 1, and we're going to get 9,198.63. And that's how much the car is worth. All right, and then number 24. Garrett signed a new cell phone contract in 2014, and the table to the left shows his average monthly bill. If the pattern continues, use geometric sequence to find his average monthly bill in 2025. So A1 is 75. And what is R? R, we're going to take 76.50 divided by 75, and that is going to give us 1.02. And N equals 12. So we're going to say A12 equals A1 times R to the 12 minus 1. Okay, do you notice that these look like interest and exponential functions like we've talked about? Because they are just the same. So A12 is 93.25. So if it continues, he will be paying $93.25 by the year 2025. All right, that's the end for this section.